Thank you for joining this lesson. We're going to study floating and sinking. Part A, Roman 1, we are taught to state the law of flotation. And this law states that a floating object or a floating body displaces its own weight, of the fluid in which it floats. So if an object is floating, the weight of the fluid displaced equals to the weight of the solid itself. Explain why a hollow metal sphere floats on water while a solid metal sphere of the same material sinks in water. So what we should know is that when the two are floating, or they are placed on the surface of water, this one is the hollow one, it is going to displace some water, and this one will give it some upthrust. Then we have its own weight acting downwards. Then the other one, which is now solid, such that inside there is no space, it is having a bigger weight going downwards, and because it has the same volume, it is going to displace an equal upthrust. Remember, in this case, the hollow one is going to float because upthrust is going to exceed its own weight. The upthrust is going upwards, its own weight downwards. Therefore, the hollow one is going to float since the upthrust is greater than its own weight. For the other case, whereby it is solid, it has a bigger weight such that even after displacing some upthrust, its own weight overcomes the upthrust. Therefore, in the second case, the weight of the solid or the metal sphere is being greater than upthrust, which is weight of the displaced water. That is why the solid one will end up sinking, while the hollow one is going to be floating. Part B, the figure below, shows a uniform block of uniform cross-section area, 6.0 square centimeters, floating on two liquids, A and B. The lengths of the block in each liquid are shown. Given that the density of liquid A is 800 kilograms per meter cubed and that of liquid B is 1000 kilograms per meter cubed, determine the part A, weight of liquid A displaced. What we should know is that the height of this block, which is in the space, is 2, the one which is floating, but the one which has sunk in A is 2 again, and the one in B is also 2 centimeters. So we can calculate first the weight of liquid A that got displaced. We should calculate first of all the volume of A displaced, which is going to be volume of the solid inside liquid A. Volume is usually given by cross-section area times height. Therefore, cross-section area of 6 and the height of 2, this gives 12 cubic centimeters. So this is a volume of the solid which is inside liquid A, which means the volume of liquid A displaced is also the same. Now for liquid A, we should know that mass is given by volume times density. And in this case, we will use a volume for liquid A of 800. We convert it to grams per cubic centimeter. It becomes 0.8 multiplied by 12. And this is going to be 12 by 0.8, giving us 9.6 grams. This is the mass. So to make it weight, we need mass times G. Therefore, mass times G, we'll have 9.6. We divide by 1000 to make it as a unit. Then we multiply by G, whose value is 10. This is going to be by 10 over 1000, 0.096 newtons of liquid A, which is being displaced. Now for liquid B, volume is going to be the same because cross-section area for the solid is 6 and the height of the solid in liquid B is also 2. Therefore, volume is 12 cubic centimeters, which means mass is going to be volume times density. A volume now of 1, because the density is 1,000, we make it grams per cubic centimeter by dividing by 1,000. It becomes 1 times 12. This is going to be 12 grams. To make it weight, we have to multiply the mass by G. Therefore, 12 over 1,000 multiplied by 10. This is going to give us 0.12 newtons. 0.12 newtons. So now, with the two weights displaced, the weight for A displaced, the weight for B displaced, we can now determine density of the block. Density, let me abbreviate density by rho, which is given by mass out of volume. And we need to first of all get mass by determining weight of this solid, rather the block. Let me call it the block. It's going to be, according to the law of flotation, which we've just stated, a floating object displaces its own weight. Therefore, its own weight is going to be 0.096 and 0.12. It has to displace liquids whose weight is equal to its own weight. And this is giving us 0.216 newtons, which means the mass is going to be, to get mass, we divide weight by G. So we divide this by 10. Then we can make it grams by multiplying by 1,000. And this will be 21.6 grams. Now with the mass, we can again get its own volume. The total volume of this block is going to be, its total height is going to be 6, because we have 2, which is floating, 2 inside A, 2 inside B, 6. So cross-section area of 6 and a height of 6 to give us 36 cubic centimeters. Therefore, for us to get what we call density now, we need mass divided by volume. Mass divided by volume. Therefore, when we divide by volume, this gives us 0.6 grams per cubic centimeter, which can otherwise be expressed in SI units as 600 kilograms per meter cubed. So that is how we get the density of the block, which is floating in the two liquids. Thank you for following. Subscribe and share.